AI is making people less intelligent. Every day you hear the news that some research shows that AI is impacting cognitive abilities, and if you think about it, it could be true to some extent. When was the last time you thought very hard about a problem? A 2024 MIT Media Lab study found that people using generative AI tools during writing tasks showed reduced neural engagement in brain regions associated with memory and attention compared to those who worked without AI assistance. This becomes even more prominent with students. ChatGPT has added study mode, but that is quite verbose and it gives answers quickly. There is also the problem of students not wanting to enable the study mode to get the answers quickly. Surveys and education research show that students overwhelmingly choose faster options over effortful reasoning when they are given the option. A 2025 Education Week survey reported that a majority of teachers believe that generative AI discourages critical thinking. Having said this, what if there is a system that gently guides the student towards the answer step by step, helping them solve assignments by themselves and thinking on their own? AI can not only dull our wits, but it can also be used to teach us things and make us think harder. Let me show you how in this video. So, to mitigate this problem, we can use fine tuning to make our models give hints instead of answers. We will see how we can fine tune GPT 4.1 Nano to respond in a briefer manner to force students to arrive at solutions to math problems by themselves. The first step to achieve this task is to find the data set that is required for fine tuning. So you can go to Data Creator AI and under Community Datasets, you can find the Socratic Teaching Dialogue Completion dataset, which has examples that can be used to train the models to answer in steps instead of just giving the one final answer whenever the user asks them to solve a problem. We will see some example conversations from this dataset and how they can be used to force people to think. You can download this dataset from Data Creator AI. I will add the link in the description. So let's see how the dataset looks. So there is a JSON object in each line where there is the field name is messages. This messages, it's an array of conversations between the user and the assistant. And each line has one conversation, and that is the JSON-L format. And for fine-tuning OpenAI models, this is the correct format that your file needs to be in. But since this is slightly difficult to read, I've expanded it into JSON so that I can show you a sample conversation from this data set. As you can see, so the messages array is expanded like this, and this is the user expressing concern or confusion regarding the chain rule. So the question is to find the derivative of a function f of x, which is sine of x squared plus 3x. In this conversation, instead of directly giving the chain rule or directly giving the derivative, the assistant is actually nudging the user to go towards the answer. So if you see, the assistant is not just giving the chain rule, they are asking the user another question. So they are asking what is the inner and the outer functions in this case. And then the user, based on their knowledge, they've answered that the outer function is sine function and x squared plus 3x is the inner function. And then the assistant tells the user how to perform the derivative of these two functions. So first the derivative of sine is cos, and then they also need to multiply the derivative of u with respect to x, which is because it's the chain rule, and the answer again is 2x plus 3. Then these two are multiplied to get the final derivative. So, and then the user, they've understood it on their own what exactly they missed in the first place. So say, if you see, they're saying I initially forgot to include the 2x plus 3 part. So that's where they were going wrong. And then finally, the answer is very clear to them. And all these conversations, they end with an encouraging message from the assistant. So this is just one of the conversations, and all of them are similar to this. So conversations like these help us to fine tune the model to guide the users towards the answer instead of giving the answer or the principle behind the answer. So if you see here, there is no definition of chain rule. It's only focusing on the existing problem. Now, in this data set, there are almost 400 data points. But let's say you want to generate more data points. You can get a data set like this in the exact format that is required by OpenAI using Data Creator AI client. All you need to do is install our SDK and then import the Data Creator AI client and give your prompt and generate a very similar data set. So let me show you how to do it. So in this code, you initiate the client and you give the theme, and you also give the number of turns the conversations should happen between the user and the assistant, and the maximum tokens and the number of data points you want. And then once you run the script, you can generate a very similar data set that we saw just now. So why is this useful? You can download the dataset from our website as well, but it is not in JSON-L format. And maybe you want to expand your dataset. In this project, we are uploading only the training dataset to the OpenAI fine-tuning job. But let's say you want to also add a validation dataset, and you also want to generate a test dataset. The model, so in this project, our objective is to change the style in which the model answers the questions. So let's say you want to test whether the model has learned that style. So now in this theme, instead of just giving generated data set where the user asks for assistance in solving math problems, you can be more specific and specify a particular area of math like trigonometry or geometry or any other subtopic of mathematics. The training data set that we have seen just now, it predominantly has questions from calculus and trigonometry. Now, let's say you want to see and test whether the model has learned the exact style. What you can do is generate a data set with maybe some other area of math. So now that we have seen how the data looks, let us see how to fine tune GPT 4.1 Nano in the fine tuning playground on OpenAI. All you need to do is go to platform.openai.com fine tune and then click on create. Then you see this pop up where you can select the method of fine tuning, which is supervised. So I am selecting GPT 4.1 Nano, and you can give some suffix or some name to your experiment, which is I've given it as meta learning. The seed, it's for getting the same results with the same parameters every time you run this job. And then you can upload your JSON-L file, which is the training data. So now that I've uploaded the training data, it shows the ID of the file. So the training data has been uploaded, and the validation data, it's optional. If you don't upload it, the validation data set will be taken from the training data itself. And these are the hyperparameters that control the training. So first comes the batch size. When we train a model, we don't feed the entire data set at once. Instead, the data is broken into smaller chunks called batches. So each time the model reads one batch and updates its weights, that counts as one training step. And the learning rate multiplier, it determines how fast the training happens. And the number of epochs is the number of times the model sees your entire data set. I will cover the hyperparameters in much more detail in another video, but for now you can just select it to be automatic. When you select auto, the system itself decides the best batch size and the best learning rate and the number of epochs for your data set and apply them. Yeah, that's it. And all you need to do is click on create. This will queue a fine-tuning job, and you can see the status of the job here. First, it validates your input files and then creates a fine-tuning job and queues it and then processes it. And this takes some time. And if you want to see the progress of how this is happening, you can check the messages here. So if you can see, after the validation of files, fine-tuning has now started, and you can see all the messages here. And one more thing is, you can also check how the accuracy is progressing and where the accuracy started and how it's changing. And it again depends on the size of your data set and also the quality of your data set. And you can also see how the loss is decreasing over time, and you can keep a check on how this is all happening. Number of epochs has been selected as 3, so your data set will be seen by the model for 3 times. One more thing to notice here is, so if you want to see how much time it is going to take or how much time is left for training, what you can do is, see, the number of epochs are 3 and batch size is 1. You can see that each epoch will have 407 steps. So 407 into 3 gives 1221. And here, where if you see, here you can see these loss graphs, and you can see the number of step the training is in. So the current step is 1205, so it might take some more time, or if the step is like at 800 or anything or something, then it might take more time. So that is how you can see how much time is left. And apart from that, you can also go through the messages, of course. And there is also periodic checkpointing, where the model that has been trained until this step is saved, so that you can start from there instead of starting from the beginning if something goes wrong. As you can see, that fine tuning has succeeded, and you can go down and see how the fine tuning took place, and also the total number of tokens that were involved in the training. Now that this job has been completed, here you have this model, and this is your fine-tuning model ID. So if you want to use it in the API, instead of GPT 4.1 Nano, you have to give this ID now. Now let's go to playground. So now this is the playground where we can compare how the model responds before and after fine-tuning for the same prompt. Now let us ask the model to solve this problem, and let's see how it responds. So if you see, the model on the left is the GPT 4.1 Nano, and the one on the right is the one model that we have fine-tuned. And if you go down, you can see that the GPT 4.1 model, it has just performed the integration and then it has just given us the answer. But on the right, if you see, this model is asking us to find the indefinite integral, which means it is first asking, okay, solve the indefinite integral first, and then we can apply this 0 to 1 and solve the equation. So here, let me give the integral of the first part of this entire term. Now it's saying proceed with the next term. The second term is x squared. Oh, okay. So if you see, I didn't include the sign, and it has corrected me that, okay, the second term along with the sign is x squared. So the responses of the fine-tuned model are not as detailed as the GPT 4.1 Nano, which was also our objectives. And this is how you can update models to behave in a certain way. Now, if you see here, the math problem did not change and the student did not change. only the AI's behavior has changed. So the model on the left, it's great while you're studying, and on the right, it is great when students are solving assignments. And before fine tuning, the AI optimized for speed and correctness. And after fine tuning, the AI optimized for a specific style and tone, and also to make us think. Now, the advantage of using these platforms for fine tuning is that you don't have to deploy it on your own servers. You can immediately use a fine tuned chat API endpoint in your app, let's say to create an educational tool like a WhatsApp study bot that enforces guided reasoning by design and not by student preference. Now, the important question is that you might also ask me, can we not just use prompting to achieve this? You can, but to understand why and when you should fine tune, you can click on the video above where I clearly discuss when and where fine tuning is applicable. Okay, so this again is a very small example of how you can fine tune a smaller module to solve a particular problem instead of using a huge model like GPT 5.2 for something very specific. And in the upcoming videos, we will experiment with various hyperparameters and solve bigger problems with bigger data sets and also smaller models, and also get into much more detail as to how to prevent overfitting and ensure maximum dataset coverage. Of course, you could also try this fine-tuning method by generating datasets on Data Creator AI and using them for fine-tuning. Thanks for watching.